What's up, YouTube? In this video, we're going to be talking about a new C# feature called asynchronous streaming or Async Streams. If you haven't watched my previous videos with regards to streaming and the iterator pattern, I'll put a link up to them over here. That in some ways is both of those are prerequisites to this video. This video may not make a whole lot of sense, and I'm not going to cover those topics. In this video, I'm going to just talk about the new C# features, how to use it, where would you use it or why when you would use it, and so on. Won't necessarily explain all the details. So if you're unfamiliar with streaming, the concept of streaming or the iterator pattern, please take a look at those two videos. Now, before I go down the path of introducing the new feature itself, maybe we should talk about what took them so long. I mean, we've had the iterator pattern since C# 3.3.5. We've had Async-Await since C# 5. So why did it take them 3 versions to come up with asynchronous streaming if we already had Async-Await in the language? And this is an interesting question because it has an interesting answer, and I seem to know or happen to know at a high level the answer, which most people actually may not know of, all right? Because the answer is somewhat sort of, let's call it internal knowledge, for lack of a better word. So it starts with when and how or why the C# language has Async-Await in the first place. And since C# has introduced asynchronous or Async-Await, other languages have followed suit and had done something similar. And in some cases, like JavaScript, they actually use async and await, which is cool. The iterator pattern was used by a person called Jeffrey Richer. He is a well-known author. In fact, one of the first few books I read on .NET and C# was his book. I think it's called CLR, that is the Common Language Runtime, via C#. And there's many additions to it. I actually own, I think, 2 or 3 editions of it. Nothing much has really changed through the whole editions. So if you haven't got that book and you're interested in reading up on some of the details and underpinnings of .NET, I suggest you pick up that book, the latest edition, whichever one that is. Jeffrey's been in the programming field for many, many years, from the C++ days, and he did a lot of Windows APIs and things, and then he's now moved to C#. As a result of his long time in the community, he has, of course, a good relationship with the folks at Microsoft. And since he's involved with the C# language, he's also got good connections with the C# language team. So what Jeffrey was doing at one point when the iterator pattern was available to us, this is .NET 3.5 days, he was trying to do something asynchronously and said, you know what, since the iterator pattern is building a state machine, maybe I could use the iterator pattern to do some things asynchronously. And he did manage to get it to work, but it was kind of like a hack. And so he took that idea to the C# team and said, listen, with the iterator pattern, we can do this. If only the code was generated this way and only if the compiler did that, we could do this asynchronous stuff out of the box without all this hackery. And so the C# team took him up on it, and they taught the C# language, C# compiler, to produce the code as a state machine for async and await. What I'm really saying is that the C# iterator pattern is compiler magic. It is the compiler generating code. After we've written our code, the compiler, when you hit compile, the compiler then takes our code and produces more code, more C# code from that. That's the lowering feature of C#. If you haven't seen that video of mine, please take a look at that video as well. The C# lowering produces a state machine for the iterator. The C# lowering for async-await also produces a state machine to handle asynchronous I/O. By the way, if you don't know or not very familiar with Async-Await and what its benefits are, please take a look at my video here on Async-Await. I made that like 6-7 years ago. It's still valid. Just you need to look at that video so you understand what I'm going to be saying in this video better. The confusion or the problem that, or the reason that we had, I think that this part is not sort of inside information. I'm just guessing that since the C# compiler is producing a state machine for both the iterator pattern and the async-await feature that we have, the language feature that we have in C#, till date, till C#8, we are not able to mix async with the iterator pattern. And if you don't know what I mean, I'll show you a demonstration of that. Not demonstration, I'll show you what I mean by code, but then conceptually, that's what you have to understand. That both the iterator pattern and the async-await pattern are producing state machines. So the compiler is not able to produce two state machines, one inside the other. That's really the complexity or the reason why we've not had async streaming feature in C# for a while. Because eventually the language team took on the job of teaching the compiler to produce state machines for a method that is asynchronous as well as using the yield return feature of the language. That is what async streaming is really about. The way you would recognize asynchronous streams in C#8 is if a method has been marked with the async modifier, and of course therefore has to have the await keyword somewhere in there at least once, but also uses the yield return. That is not something we can do in language versions prior to C#8. Now, that's fine. That's how you can recognize the feature, but what's the value? What's the purpose of the feature in the first place, right? Well, if you watch my iterator video and my streaming video, imagine the combination or the benefits of these two things while also being able to do stuff asynchronously. So let me briefly give you the reasoning or the value for async-await. Async-await is to be used when you're doing IO-bound workloads, when you're making network calls or database calls or reading the file system, talking to a service, stuff like that. IO-bound workloads. You should be using async-await. Now, async-await is not about performance as much as it is about scale. You won't get the performance because you made something asynchronous. In fact, you might be getting a little less performance depending on how often or what your system needs to scale at or what it needs to scale to. But essentially, async-await is all about scalability and not performance. And I explain scalability in my async videos. So if you need to understand what is scale, most people don't understand what scalability is. If I said my system is scalable, like what, did I just pull it out of my hat, or do I know for a fact that is scalable? How do I know if it's scalable? How do I test to see if a system is scalable? What does it even mean for a system to be scalable? Asynchronous I/O is about giving your system the ability to scale, especially when it's a lot of IO-bound workloads involved, calling databases, calling external services, stuff like that. But that's almost like saying in prior versions to C#8, language versions prior to C#8, it's like saying, well, if you're doing IO-bound workloads, you also can't use the streaming feature, which is actually a benefit. Sorry, that didn't come out right. It would be cool if we could mix or combine IO-bound workloads along with streaming. When would you want that? Well, of course, anytime you're doing IO-bound workloads where the data is coming or chunks of data are coming across to you, if you can stream that data, then you are receiving the data as soon as it becomes available to you rather than having to wait for all of the data to be available to your server side before you, let's say, your front end is able to see it, or your console application or your MVC controller is able to see it. Data comes across I/O in packets or in chunks. It comes in starts and spurts. It's not like it comes as a continuous stream from server A to your application. It comes in spurts, and depending on network congestion, those spurts could be slower or fewer packets of data come across in every spurt. And if you are not using streaming, and if you understand the previous video on streaming, then you would understand that you're waiting for all that data to come. Even though you have 10 records, just because you're waiting for that 11th record, because that's the last record, the front end is not seeing the data. With streaming, you're able to provide that data to your front end or to your web API controller, whatever it is, however you're consuming it, as soon as the data becomes available. And of course, the delays come because of network calls. So if you could stream your network-based calls as well as get the scaling feature or scalability feature of async IO, you get the best of both worlds. That's just something we've not been able to do until C#8. And that's what the feature of C#8 is all about. Hopefully that makes sense. All right. This project is quite a bit more modified from the previous one. So I'm going to have this project available on GitHub. This project is the C#8 Async Streams project. I'll put a link to this project on my GitHub in the show notes below. It has two methods, the async without the streaming, and then the async with the streaming. Now there's a lot of code you'll see even in the project here. There's a ton of code classes. Those are all supporting classes. Okay, so don't get all worried about, oh my gosh, there's a lot of code for me to understand. This is just supporting classes. And it's unfortunate because I was trying to make an application that's more real worldish, and so it needs more classes. Essentially, it's a system that relies on a database, and here's the database project. This is also part of the solution that I'll be putting up on my GitHub. You can produce this or publish this database simply by right-clicking here and doing a publish. If you've not, I won't teach you the details of that, but essentially you can recreate that database on your local machine. And then I have a method here that you would have to uncomment and comment out everything else to then create some random data in your database. And once you create the random data, you can then run this project. It's also got the benchmark.net associated with this project, so you can also do the benchmarking and see the difference. Now, again, this is not about performance. This is about scale because of the fact that we are now able to use things asynchronously, but it's also about streaming. Now, you won't see the real value of the streaming here in the sense that there's no way for me to easily demonstrate the benefit of streaming along with asynchronous, but I can explain that to you before we move forward. Remember I said the data comes across the network typically in starts and spurts. It's not like one continuous non-stop stream of data coming from your server to your web application or from your controller to your UI, right? It comes in packets, and depending on network congestion, the packets could be smaller chunks of packets or could take longer between packets. But if it's streaming, and on your end you're doing a pull, and that's the other difference between streaming, async streaming as we call it in C#8 now, it's a pull-oriented concept. It's not a push-oriented concept, as in you have to have code that is for-eaching through that stream. So effectively it's pulling the data as it's coming down the pike. But it's going to have to wait, like, when it tugs on that rope and there's no data, it's going to just wait until data arrives. And as soon as the data arrives, it starts to move through the data. So you could have your UI being responsive even as soon as it gets that first record. It doesn't have to wait for all of it to appear. So the user's not waiting around for all the data to appear. You follow? So hopefully that makes sense. So that's a pretty cool feature. And if you have a UI, depending on what you're doing with this data, you might actually see the data arriving in starts and spurts because that's really what's happening. The C# code is pulling on this rope, if you will, waiting for the data. And as soon as the data comes, it moves forward and is waiting on the next bit of rope and so on. So if you are, let's say, printing out to the console, you will see the data appear in your console in starts and spurts. And you can simulate this with writing a server application that intentionally delays the streaming part, by seconds each time. And so you can see that on the console, it comes in starts and spurts. But I haven't done that in this project. I've kept it sort of simple just to get the concept, and the code is available. You can modify the source code, or you can build your own server application that streams the data to you in the starts and spurts thing. So you can simulate that scenario, and then you can see the benefit. All right. So now for the code, I already have my database data initialized, so I won't need to use this. And I'm just going to show you the movie data manager class that has the two different methods. One that has the get all movies that is asynchronous, and it returns a task of IEnumerable of movie. So similar to the code from the streaming project, that video. So it's just a little difference, the fact that this is asynchronous now. So because this method has been marked with the async modifier, it has to have at least one await. And since we're doing a bunch of I/O workloads here, we are opening connections, we are executing readers. These are all asynchronous. We can call await on these things to get the asynchronous feature. And then same method from before, we just map the data reader that's coming from the database into a collection or a list of movies, and we iterate over the records. And for every record we find, we map it to a movie and move on and eventually return the collection. So this is asynchronous, but it's not streaming yet. This is just asynchronous. Now, as I said before, because of the machinery that was building or generating the iterator pattern and the same machinery that is generating the async-await state machine being similar, the machinery, the C# compiler, wasn't able to handle an asynchronous method doing a yield return. So if I tried to do a yield return, this would actually not work. The compiler will complain, so you can't do this. All right, that's the limitation we have. So this method, even though I could be using async streaming here for demonstration purposes, I've intentionally left this method as asynchronous, but not streaming. This map movies is not doing a yield return, it's doing a return. Right, so there's no yield return in the entire path here. It's doing a return here and it's doing a return here. Whereas I have another method called getAllMovies async streaming. This is also marked with the async modifier. And the difference here is it's now returning an async enumerable rather than an enumerable. And the big difference here between async enumerable and enumerable is one returns a task, the other returns a value task. Now, value task is not new to C#8. It's been, I think they introduced in C#7, forget which point version of 7 now, but it's been there since C#7, I think 7.2. They're using that over here as a optimization, and you see some of the optimization in the benchmark results when we run it. Value task is not the same as a task. It's not the same thing as a task, except it's a value type rather than reference type. There are some caveats or constraints to the value task. So don't just substitute a value task to a task. Now that you learned there's a value task in the system, it gives you some benefit in performance or memory allocations or fewer memory allocations. But in this case, the method that is streaming needs to be asynchronous and should be returning an async enumerable, right? And in this method, the big difference between this method's implementation and the previous one is that it not only has the awaitables in here, like we have the await here and the await here for anything that we're doing I/O bound, we're also yield returning it in the same method. And this is what was not possible in prior versions, language versions prior to C#8. And the reason I'm harping on this over and over again is because a lot of people think async streaming is, I don't know what it is that they think, but when they start talking about it, they don't quite have a clear understanding of it. And I want to make sure you understand that it's the combination of asynchronous methods that can also yield return. This was something we were not able to do prior to C#8. The code here is sort of the same thing. It's creating a new movie instance, and then it iterates over the records in the data reader, and it populates or sets up the property values, and it yield returns the movie instead of returning the movie, right? So we're getting the iterator pattern in combination with the asynchronous capability, whereas in this method, we are not using and we are not able to use because this is returning an enumerable, which is a task of returning a task, versus this returning an async enumerable, which is returning a value task. All right. Now, as I said, async streaming is about a pull concept rather than a push concept. Pushing is like events. Like if you're in a message broker of sorts, then those message brokers are pushing events to you rather than you pulling the events from them. And so async streaming is a pull concept or technique. So in the program CS, my two benchmarks, and it's not about the benchmarks, I just happen to have a benchmark application for this purpose. You're going to see there's two benchmarks. One is getting the values with streaming. The other one is getting the get all movies without the streaming part. So let's look at this thing here. It's calling this method the non-streaming method, but it's asynchronous. So this method is marked with the async modifier. And in this case, it can be marked as a value task of int instead of a task of int. Both will work. They won't complain either ways. And you pull, as in this for each is not doing the pulling. Right? So as the for each is trying to get the data, it's going to start doing the pulling. That's what a for each is doing, is pulling the data. Now, if it's not streaming, it doesn't actually pull it in that sense. But effectively, if it's streaming, it's pulling that data. But this is standard implementation. This is just asynchronous. It's not streaming. The implementation here, however, for this method, for the get all movies async streaming method, is got an awaitable for each. And this is, again, a new part of the support for the streaming, language support for the streaming. So we have an I async enumerable, I async enumerator. We have, of course, value task is needed for the support. It wasn't introduced for this feature. We have an awaitable for each. We have an I async disposable. These are all part of the language features required in order to support this one feature. I'm only talking about the parts that I'm showing you here. In other words, I'm not talking about I async disposable. All right. So the syntax for the awaitable for each is you await the for each, and then you can either call, this could be a variable, I'm just calling it right here, some method that is doing an async stream, and then this is doing the pulling. By iterating over this async stream, you're effectively pulling on the stream. You're waiting for the data. So in case the data is, all of it is not come yet, that for each is going to be waiting for the data to arrive, and if only one record comes, it's going to consume it and wait for the record again, and so on. So it's a pulling concept. And then it's done. So I'm not sure what to show you here. I'm going to run the benchmarks just so we have that sort of on file, on record. Keep in mind, this is not about the performance, but because of the fact that the value task is being used as a return type, you'll see some fewer memory allocations, or certainly you'll see an idea, or if you understand generation 0 and generation 1 in the heap, you'll see 0 gen 1 allocations for the streaming version, and you'll see gen 1 allocations also happening for the non-streaming version. Performance-wise, I don't expect any major difference. They're almost neck and neck. Any benefit you're going to see is purely a fluke or negligible, so you can't actually call it a benefit. So we'll see what the outcome of this is going to be here. It should be done any minute. All right. So what I'm seeing is that they're almost neck and neck. The async streaming is just slightly faster than the non-streaming version. But if you look at the allocations here, you see that the non-streaming version is allocated more memory than the streaming version. And the non-streaming version has Gen 1 allocations occurring as well. So this is going to cost you, as in, I don't know if you know this, but I'll give you a very, very short idea about memory allocations and garbage collection in .NET. In managed languages, allocations are not the problem. It's the deallocations or the garbage collection. So the more garbage you produce, the more garbage has to be collected. And that's when your application takes a hit. So even though allocations are fast in .NET, and they don't sort of cost you in that sense, time-wise, the cost is going to come in terms of performance from a deallocation standpoint. And then on top of that, if your allocations are moving from generation 0 in the garbage collector to generation 1, it's going to cost you even more, right? I'm not going to give you a whole thing on garbage collection in .NET, the generational garbage collection. Just a brief, just keep that basic thing in mind. So in Gen 0, there are these allocations occurred through the benchmarking. But in the stream version, there's been no Gen 1 allocations. Plus, the total number of allocations or number of bytes in the allocations for the streaming version is less than the non-streaming version. All right. So I'm hoping I've covered everything you need to understand here about the new feature on C#8 on async streaming or async streams. the how, the why, the when, and the when not. Did I cover the when nots? Well, it's best to use this for the pull scenarios and not for the push scenarios. It's not intended for, even if you hack your way into it, it's not intended for that. Now, there is no LINQ support for async streams. One would think that there would be. Microsoft is not doing the support. There is a community project, I forget what it's called now, and I haven't had a whole lot of experience with this, so I'm not going to talk about it much. But there is a project, a community project, that supports LINQ streaming. And you can imagine it's the combination of being able to do like a where that is doing a pull and is iterating over this streamed collection. And so the where is now pulling, if you will, and it's deciding whether the record it just got is matching the criteria or not, and return that. So it'll be nice to have LINQ also support streaming, but it's not something that Microsoft itself is doing. The community is doing it. Eventually, I'm sure it's because it's all open source now. At some point, it'll be well supported and stuff like that. So not by Microsoft, just generally in the community. All right, I think I've done my part here. If you have any questions, please leave those in the comment. If you've watched this video so far and you liked it, please subscribe. Please hit the notify button. Please give me a like, and I will see you next time.